projects. In this video, we are going to explain about a project titled Fake Currency Detection using Machine Learning. The fake currency refers to the illegal production of currency that closely mimics the physical characteristic of legitimate banknotes or coins. The main goal of the counterfeits is to trick people and organizations by creating the replica that appear authentic, aiming to deceive and defraud others. The fake currency presents substantial risk to both the economy and society as a whole. It can result in financial losses for individuals and businesses, undermine public confidence in the monetary system, and potentially contribute to illicit the activities by providing a source of illicit funds. The objective of this project is to utilize the machine learning algorithm for efficient fake currency detection. The focus is on evaluating the performance of several algorithms, including SPM, decision tree, naive Bayes, and KNN. Various metrics such as accuracy, precision, recall, and F-score will be used to assess their effectiveness. Ultimately, the aim is to develop a robust system that can effectively detect the fake currency. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that developed to build this project. The first module is upload the fake currency dataset. This module allows user to upload a dataset containing the information about fake currency. The application will read the entire dataset and extract the necessary features and labels required for training and the testing. The second module is data pre-processing. This module focuses on preparing the dataset for training and testing. It identifies missing values in the dataset and replaces them with zeros to ensure the completeness. The dataset is then normalized between the 0 and 1 to bring the all features to a similar scale, which help in efficient training of the machine learning model. The pre-processed dataset is then split into two parts. The training set that is of 80% of record and the testing set that is of 20% of record. Third module is run KNN algorithm. In this module, the pre-processed training data is fed into the k nearest neighbor algorithm. This algorithm is a type of supervised learning that classifies the new instances based on their similarity to the existing instances of the trained data. The algorithm is trained on the training data and the accuracy of the model is calculated by applying the test data. And the fourth module is run naive Bayes algorithm. This module utilizes the naive Bayes algorithm to build a machine learning model for fake currency detection. Naive Bayes is a probabilistic classifier that assumes the independence among features and calculates the probability of a sample belonging to a particular class. The pre-processed training data is used to train the naive Bayes model, and the accuracy of the model is evaluated using the test data. And the fifth module is run decision tree algorithm. This module employs the decision tree algorithm to create a model for fake currency detection. Decision tree algorithm builds a tree-like model of decisions and the possible consequences based on the features in the training data. The pre-processed training data is used to train the decision tree model, and the accuracy of the model is assessed by applying the test data. And the sixth module is run SVM algorithm. In this module, the pre-processed training data is utilized to train a support vector machine model for fake currency detection. SVM is a powerful algorithm that separates the data points into different classes by finding an optimal hyperplane in the high-dimensional feature space. The seventh module is comparison graph. This module generates a comparison graph that illustrates the performance of different machine learning algorithms used for fake currency detection. The graph shows the accuracy and the other metrics of each algorithm, allowing the easy comparison to determine the most effective algorithm for the task. And the final module is fake currency detection from the test data. In this module, users can upload the test data to the application. The trained machine learning model, which has been previously trained on the pre-processed training data, is then used to predict whether the test data corresponds to the fake or genuine currency. This module provides the prediction result based on the trained model, enabling the user to identify the potential instance of the fake currency in the test data. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of test data and banknote data. And the main is a code file, and table is an HTML document file, and the run is a bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, we need to click on Upload Fake Currency Dataset. By this, we are redirecting to the dataset folder and then click on Banknotes and click on Open button. Here we get a graph represents of counterfeit notes frequency, that is 0 and 1, in x-axis, that is of counterfeit frequency or not, and the y-axis represents the count of this counterfeit frequency. And we can see the dataset is loaded, and the dataset before pre-processing, here the length left, right, bottom and top diagonal. And then click on Data Pre-Processing button. Here the data is pre-processed, and after the feature normalization, here the data is off, and we can see of total records found in the dataset is of 200, total features found in the dataset is of 6, and here the dataset is split into the training and testing part. 80% of dataset is used for training, and that is of 160, and 20% of dataset is used for testing, that is of 40. And then click on Run KNN Algorithm button. By this, the KNN model is generated on the pre-processed dataset. Here, this is the confusion matrix, where we can see only one record is incorrectly predicted. Now close this graph. Here, KNN gives an accuracy of 97.5, precision of 97.3, recall of 97.7, F-score of 97.48. And then click on Run Naive-Bayes Algorithm button. By this, the Naive-Bayes model is generated on the pre-processed dataset. Here, this is the confusion matrix for the Naive-Bayes, and we can see that no record is incorrectly predicted. We can say it gives an 100% accuracy, and close this matrix. Here, this Naive-Bayes gives an accuracy of 100%, precision of 100%, recall of 100%, and F-score 200%. And then click on Run Decision Tree Algorithm button. Here, the confusion matrix is generated, and the decision tree is generated by using the pre-processed dataset. And we can see that only of 0 records are generated by using the decision tree algorithm, and it gives an accuracy of 100%, precision of 100, recall of 100, and F-score 200. And then click on Run SVM Algorithm button. Here, the SVM algorithm is generated on the pre-processed dataset, and we can see that more number of records are incorrectly classified. So, by this, it gets of less accuracy when compared to the other algorithms. Here, it gives of SVM of accuracy 45, precision of 22, recall of 50, and F-score of 31. And then click on Comparison Graph button. Here, this is the bar graph which represents of the x-axis of algorithms we use, and the y-axis represent the value assigned for the each algorithm for each metric. And here we consider of 4 metrics for every algorithm. The blue color bar is of accuracy, orange bar represents F1 score, and green bar represents precision, and red bar represents recall. This is the table representation of each algorithm and their metrics and their count. And close this table and click on fake currency detection from test data button. Here it redirected to the dataset folder, and we need to select the test data from this folder and click on open button. Here the data that present between the square bracket is of the test record, and after the arrow symbol we can predict it as a fake. For this record we can predict it as genuine. For this test record, we can predict it as genuine. For this test record, it predicted as fake. In this way, we can predict the fake and genuine notes by using the machine learning model. In conclusion, preventing the fake currency is crucial for maintaining the trust in financial system. The integration of advanced security measures, human expertise, and machine learning algorithms offer the effective means to accurately detect and combat the fake currency, safeguarding the economies and individuals from the financial harm.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.